first example we're going to do is we're going to do an example where the object is further away from the lens than the focal length. So the object is here, the object is going to be 10 centimeters away, 10 centimeters from there. Focal length is 4 centimeters, and I've made the object, sorry, that's HO. We've made the object 4 centimeters high. So the first thing we're going to do is draw on the lens shape. That just lets us know what's going to happen here. And then we've got 3 lines that we can draw in. So the first is parallel, then F. So what I'm going to do is I'm going to draw the ray of light. So the ray of light leaves my object, goes along parallel, to here, and then once it hits here, it does, with the mirror it reflects, with the lens it transmits, so it goes through here, and we'll draw through there from that line of action through F. So this is going to be line 1. Line 2 goes through F, then parallel. So that means line 2 we draw, because it's going to meet F before it meets the line of action, we're going to use this F. Remember the distance when you're drawing this F in, it's the same distance as this one. So this is 4 centimeters, 4 centimeters. It then goes parallel. And the third ray that we put in is go through the center of the lens. So the third ray, we'll check my quality of my draftsmanship, goes from the object through the center of the lens and should hopefully end up with all the others. Yay! And then we can draw in the image. The image is going to be here. So what can we say about the image? Well, in this case, the image is, well, we've got upright, inverted. Looking at that, we can clearly see that that's upside down, so that's inverted, enlarged, reduced. So in this case, it's reduced, but the closer I get to F, the bigger that image is going to get. It can get really large. In fact, this is often what we do in a cinema, when you go to a cinema, a motion picture camera or projector. You put the picture close to F and it becomes really large. Hold far away, it gets really small. Okay, and what else do we need? Real or virtual? Well, if I were to stick a piece of paper there, I would actually see a pretty little image. Remember, my eye is over this side. This is what my eye sees. I'd see a pretty little image if I put a piece of paper there. I'd see that arrow upside down, so that means it would be real. And then if I want to find out DI and HI and probably M as well, well, either I can do that with a ruler. I can go, well, let's see, how far is that there? That's 6.5 centimeters. 6.5 centimeters. How big is it? 2.5 centimeters. And then M equals HI over HO. L equals 2.5 and 6.5. 0.385. what we can do is we can use maths to confirm this. So F inverse equals DO inverse plus DI inverse. Therefore, rearranging this, DI inverse was F inverse minus DO inverse. DI equals F inverse minus DO inverse. You can take the inverse of the lot. So DI equals, F is 4 inverse minus 10 inverse, because 10 there. Take the inverse of the lot equals, calculator time, 4 inverse minus 10 inverse equals, take the inverse, 6.667, so 6.67 centimetres. What did I have? I had 6.5, so that's all far out, And then the height of the object, remember, height of image over height of object equals distance image of distance object. So height image equals height object di do, which equals the height of the object was 4 centimeters times distance of 6.67 over 10 equals times 4 by 10 equals 2.67 centimeters. Okay, so again, this is close to this. This is going to be more accurate than this. This was measured, this was calculated. And then the last one is M is going to equal HI over HO equals, what's HI? 2.67 over HO 4 equals 0.667. Magnification is equal to 2.5 for 2.5 divided by 4 equals 6.25. So once I got the right numbers in there, the magnification was 625, and then once we did this 2.67, we actually found out it was 0.667. Okay, so as a rule, calculation tends to be much more accurate than ray diagrams, but ray diagrams give us a visual representation of what's happening, and you can get reasonable results out of using ray diagrams. So next we'll do convex lens when f is greater than the distance of the object.